Well, friends, I would like to divert your attention towards the atomic physics. Introduction to the atomic physics. Atomic energy is the source of power for both nuclear reactors and nuclear weapons. What is that atomic power? Atomic power is nothing but the nuclear power, my dear friends. Let us have a close association with atomic physics and nuclear physics. It is one and the same. They are like two sides of the same coin. Atomic physics and nuclear physics. Well, friends, this energy comes from where? Splitting. Splitting means what? Fission. Nuclear fission. Fission means what? Breaking fragments or fusion. What is the joining? Fusion means what? Unifying or unity. Uniting together of atoms. So, the atomic energy or the nuclear energy are of two types. One is nuclear fission and nuclear fusion. Fission means breaking and fusion means uniting together of two atoms. There is a possibility of understand the source of this atomicity or atomic energy. One must be first understand the importance of atomic physics. Atomic physics is the field of physics that studies atoms as an isolated system of electrons and atomic nuclei. It is primarily concerned with the arrangement of electrons around the nucleus and the process by which these arrangements change. That means atomic particles and subatomic particles, electrons, protons and neutrons. So, my dear friends, here you see atom as a whole. Atom consists of the nucleus, and nucleus is made up of proton and neutron. We have already discussed in our previous classes about the electron, proton and neutron. So therefore, atomic physics and nuclear physics going side by side. They are like two sides of the same coin. Let us have glance over the atomic physics and nuclear physics. Discovery of proton, I would like to divert your attention towards recollecting the memory of Rutherford's gold foil experiment. In 1909, you know that Rutherford discovered proton. Gold foil experiment we have already discussed. In this atomic physics, the experimental setup of Rutherford's gold foil experiment weighs the deflected particles, the detecting screen, the gold foil and the alpha particle emitter are the important things. Most of the volume of an atom is empty space. The number of negatively charged electrons dispersed outside the nucleus is same as number of positively charged in the nucleus. It explains the overall electrical neutrality of an atom, my dear friends. This is the atomicity or the atomic physics. And Rutherford gold foil experiment tells most of the observations about the entire positive charge are confined in a small core called nucleus of an atom. The particle, electron, proton and neutron, the symbol, the charge and the mass are respectively given in detail. Discovery of neutrons. Topics related to nuclear physics are nuclear fission, nuclear fusion, difference between nuclear fission and nuclear fusion, types of radioactive isotopes. What are isotopes, my dear friends? Isotopes, radioisotopes are nothing but same atomic number but different in atomic weights. Same atomic number and different atomic weight. Suppose uranium 92 238, uranium 92 236. So same atomic number with different atomic masses gives you the radioisotopes or radioactive isotopes. And further, difference between mass defect and binding energy and nuclear reactors, fundamental forces of nature, types of radiations, properties of alpha, beta and gamma rays, difference between natural and artificial radioactivity, half-life of radioactive elements. These are the very important concepts, the fundamental concepts, basic knowledge of nuclear physics, my dear friends. Thank you.